right. Hello, welcome to Sinopia Sprint 4 demo. My name's Saurav Shah, and I'm a developer at Stanford on the Sinopia project. So this is the homepage. We're using JavaScript ES6 and React.js with Jest and Enzyme for unit testing. Here we have the header with the link to the profile editor, so you can see. We can go back and have this drop-down menu with the help and resources with some links. When we click on the link, it opens up a new tab to that path. Here we have the latest news panel. This is where Astrid and Michelle will be updating the news. Here we have a stub for the username and password for authentication. We will formalize this in upcoming sprints. Here we have a description of the linked data and libraries and the footer down here. Now I will be passing the mic to Robert.
I'm Rob Smith. I'm one of the operations team members, and I'll be talking briefly about our Terraform setup. So currently we are running this in AWS, and I'm actually going to break it on purpose so that we can see how it will work. We have a Terraform setup in our dev environment. So we now have no tasks and no services, and if we go to the Sinopia homepage, you'll see that it's broken. In Terraform, I'm going to run a Terraform apply, and it should spot now that the service and tasks are not running, and it will start them up for us. And it's just telling us what it will be doing. This should be done in just a second here. And it's done. So we can come back over here to the AWS console, and there's the service again. And if we go into the task, we'll see that it is pending. Pending means that the Docker image is currently being deployed to it. Just as a test, while that's waiting, I'll run another Terraform apply just to make sure that the state in AWS, the service and tasks are exactly how they should be. And zero added, zero changed. We can come back over here. And we just need to wait just another 30 seconds to a minute here for that pending state. While I'm waiting for this, I'll say that the continuous deployment and continuous integration features are currently in progress, and we should hopefully be having those soon. The reason for the pending is there are AWS health checks, and so it's not going to show that it's currently ready until it has passed all of those health checks. There we go. So now it is running. Let's try one more time. And the site is back. I'm going to pass it over to Naomi, and she's going to show us some more cool features.
Okay, let me share my screen. This is the state of the profile editor in our master branch right now. And what we've worked on this past sprint have been populating some of the things that were being loaded from a Verso backend from the Library of Congress, which we are not using. and tests. So in terms of things populated, we were populating the ontologies, which can be displayed because when you are in this view and you is this the one? Yeah, when you get to this box, this was previously completely empty, and now you see we're loading these 5 OWL ontologies. Another thing that was changed is that this box was also empty, and now it is populated with the same things that are in the BibFrame editor from the Library of Congress. Aside from that, we've beefed up our tests, and I think I'm sharing the wrong thing, so give me 1 second. And I will show you, it's not the world's most interesting UI here, but I'm going to run the tests. And we have created from no tests at all in the beginning of this project, we have created a whole bunch of tests. We still have some that fail intermittently, but you can see that we've created 71 tests that are basically going after the functionality we don't want to break. And this particular failure is likely just a timing race condition thing that would go away if I ran it again. That ends our demo for today. We'll see you next time. Oop.
You have one more thing.
Oops, sorry. My bad.
Okay.
I'm handing it over to Darcy. Christina. I'm handing it over to Christina.
So all of the work we've seen so far has been focused on the front end, which is a huge part of this project. However, there has been work going on for the server that's going to be sitting behind these JavaScript applications that are being developed. And I want to give a brief update on behalf of John Martin, who is not here today, on where we've gotten with that work. And so I'm going to share my screen. Let me share desktop 1 and make sure I have do not disturb on. I'm going to start here. So our server, this is the server that's actually going to have managed persistence of the resources that are being created, profiles or otherwise, through these front-end JavaScript applications. So the database, it's identifier management, it's permissions management about who can do what to what resources. And we are following LDP, a W3C protocol that creates a REST API specification for linked data resources to do this. That's a specification, that's not a code base. So we look to the community, and Trellis is a code base by Aaron Coburn, who was formerly a Fedora core committer and just active in our community. Trellis is a code base, is a Java code base that has configurable backend options that gives us an LDP server. So in the last week or so, we've been experimenting with Trellis to see if it can cover a majority of our requirements for the server so that we don't have to write that code on our own. Luckily, it seems like it does. This is the website for Trellis if you want to see more. If you want to see our draft notes, it's on the Sinopia server GitHub repo wiki. These are very rough drafts, but you can see our technology selection criteria for the server and what I'm about to show you, which is walking through actually creating some resources, including permissions on that server running locally. So these are just all the commands right here to test that it can actually take something from those front-end services, authenticate a user, check their permissions, and then actually persist or return the resource. All following HTTP and W3C specifications. Just as a very small example, so you'll see up here, I'm logged into Postgres on my computer, and I'm showing for local running of Trellis, and this is Trellis with no extra configurations from us, except for pointing at this empty database in Postgres. We have a Sinopia database, and it comes automatically with these tables after migration from the Trellis codebase. Resources is where actual linked data resources get created. Description is where the non-LDP or container-specific metadata gets stored for each one of those resources. ACL is web ACL, which is our authorization permission that also gets stored here and is referenced by resources. Then you can see some other database management and logging. We also have coming with Trellis Memento, which is a versioning spec that allows us to keep versions based on timestamps of all of the resources in the server, which is nice. So running this, I'm gonna just try to make this a little bit bigger. I can't get rid of all of this because one of these is Trellis that was actually running on my computer. But if you just wanted to see some examples of what we're talking about, you can do a curl on, I have Trellis running locally, so it's localhost 8080. And I'm gonna just do the core. This is a base container or a basic container for the server that comes as soon as you spin it up. You're not gonna really keep a lot here, but this is where you can define Sinopia.io/resources might be our base container for all of our linked data resource URIs. So this is where it would be driven from. It helps describe what the server's expectations are. If you wanted to see more about that, I just put really stupid basic metadata on it. You can update it using post or patch HTTP or put. You can delete it, but it'll really mess up the server because it's your base container. One of the interesting things about that is that with Trellis, we get, actually Fish is going to require me to do this. Let's add ACL. It has this automatic redirect for you that will let you see, and you're going to see my top secret password. So running this command, I just appended extension ASL parameter to that container, and it retrieves the ACL permissions document. This is the default permissions for everything on that server. So and it's all using ACL modeling. So here at the bottom, make this a little bit bigger. Authorization to read is given by anyone who is a FOF agent, which is basically anyone, and they can read anything here. And then authorization to control or write is given currently just to me. You say I have a fake out web ID. This is coming from the solid specification out of MIT. We don't have to have resolvable web IDs for users, but if you do have one, you can use it here. This would just be some way for us to sync up with the authentication layer in the front end, because that's what's going to be encoded and passed with the request. And it tells me what I have access to. So within that, if I wanted to say, add a new group, and you can see in our resource models page, groups are just what we're using as loose containers of who are groups of people that agree that each other can edit their resources, PCC, non-PCC, Stanford, Cornell, whoever. These are containers that sit below that basic container, and you can actually add one if you would like by doing a post. Let me just see if I can get Fish Shell to perform magic for me and just pull one up. So here I'm saying I want to post against the base container, which LDP spec, that means create a new resource within it and automatically create that relationship for us. I'm calling Stanford JSON LD, which is JSON LD in my local file system that just is linked data that describes the Stanford group. I'm saying it's going to be of type basic container. So it's going to be something else that has that trick of where you post against it, it creates a resource within it and does that auto containment for you. And that we're sending JSON LD. The slug is I would prefer to get the identifier Stanford if possible, and we'll see if it lets us do it. And because you have to have a user that's allowed to do writes, we've got myself at the end. The interesting thing here is we get all of the HTTP semantics by default from Trellis. I've already created Stanford. Maybe you want to do something else. If I open let's make Columbia out of respect for my previous employer. If I just add, here's the JSON LD for them. I'm going to call this the Columbia group. And I'm going to just remain as author. And so that's been saved. I want to call this now Columbia. And I'm going to call in this file. It's been created. It gives us the link of where it's at, that location. So if you can call curl I, there we go. We've got our metadata for that Columbia group. It's a very similar pattern to create a resource then within that group, a resource being whatever thing they actually create in the editor and once saved. It's also very easy to create lower level web ACL permission documents and have them apply to a group. So my next step here might be to create a new ACL document, post it at the appropriate place to have it refer to Columbia. And then Columbia will say that I can edit there, but I can't edit perhaps at Stanford. And then just sort of a minimum, like just a bonus. We have a silly little UI that comes automatically from the Trellis server, and you can see this is how we can do automatic dereferencing of all the URIs that we create. So next steps there, we have to see deployment patterns for AWS, and we have some ideas for that, and to continue to expand on these curl and data specifications so that we can have it there for writing the client for the front end and build out those expectations. So, is there anything else for the demo? All right, thank you for watching. If you have questions, you can leave them in the comments below the video or get in touch with a member of the crew.